So PeroxyChem provides a broad portfolio of different technologies for in situ and ex situ remediation. These technologies include in situ chemical oxidation, in situ chemical reduction, aerobic bioremediation, metals remediation, enhanced reductive dechlorination, and NAPL stabilization mass flux reduction technologies. So as I'm sure most of you are aware, or if not all of you are aware, different types of contamination need to be treated and use different technologies. So we provide a number of different products to try to meet all of these needs. This includes the in situ chemical oxidation technologies, the Klozur portfolio, which is what we're going to be talking about today. The portfolio includes Klozur SP, sodium persulfate, Klozur One, which we'll be talking about today, Klozur KP, which is based on potassium persulfate, and Klozur CR. Our in situ chemical reduction technologies include EHC reagent, EHC liquid, and Deramind, which is more for a surface type of application. Deramind, again, for a surface type of application. Permiox Ultra, both the fine and the granular, are aimed to support aerobic bioremediation. Metafix is our lineup that is used to support metals remediation, stabilization. And then to support enhanced reductive dechlorination, we have the ELS microemulsion and ELS concentrate, and ISGS for NAPL mass flux reduction. In addition to our products, or in support of our products, we also try to provide a series of services, and this includes a treatability laboratory, the rental of mixing and handling equipment, technical and design support as needed, occasionally field support, and then we have people within PeroxyChem that have experience applying and implementing and designing all of our different technologies that you can contact and discuss any questions that you may have. So really quickly, I will start this webinar by overviewing Klozur Persulfate in the portfolio. Then we'll get into Klozur One, introduce you to it, what it is, exactly what we intend it and how we view it being used, technical data regarding the efficacy of Klozur One, a series of recommendations on how we think Klozur One should be applied. Then we'll talk about how Klozur One fits into the overall Klozur portfolio. And then we'll finish this off with a series of summary and conclusion slides. Overall, the Klozur Persulfate portfolio, or what puts the product into our Klozur Persulfate portfolio, is its ability to dissolve and release the persulfate anion, which you can see here on the left. Persulfate anion is essentially two sulfate molecules that are bound at the oxygen-oxygen bond there in the middle. The persulfate anion is a strong oxidant. It can be activated by a number of methods to form a variety of radicals. These radicals are actually thermodynamically different than than sodium persulfate, the persulfate anion. They can be stronger, both oxidative and reductive radicals. And because you can form both the oxidative and reductive radicals, you can actually use Klozur to treat a very wide range of different organic contaminants. The persulfate anion itself is relatively slow in reacting. It reacts with different things fairly kinetically slowly. Because of this, it actually has a pretty hot extended half-life in the subsurface. We tend to see it persist on the order of weeks to months. It's actually the radicals that are formed that are the primary reactive species, and they tend to react with different compounds almost instantaneously when formed. So basically, the persulfate anion, its stability allows it to be distributed out into the subsurface, and then it is slowly decomposes, it slowly is activated to form the radicals and treat the contaminants of concern. This process, one of the other great advantages of the Klozur Persulfate products, is the fact that as they decompose, they form little to no heat or gas. Getting in a little bit more detail about the different radicals, you can see the persulfate anion here is a pretty powerful oxidant in and of itself. It's thermodynamically powerful. It just reacts kinetically somewhat slowly. But thermodynamically, it's more powerful than hydrogen peroxide, permanganate, chlorine, and oxygen. But it can be activated to form these different radicals. And this includes the hydroxyl radical and the sulfate radical, which have the standard reduction potential of 2.6 and 2.4. But it can also, under certain circumstances with specific activators, can be activated to form a reductant, the superoxide radical anion, which actually has a standard reduction potential below that of sulfate reduction and approaching that of the zero-valent iron, ZVI. So basically, you can, out of a single system, have both oxidative radicals and an oxidative pathway, and reductive radicals and a reductive pathway. Also, superoxide and hydroperoxide, which happens to also be formed in alkaline activation, are nucleophiles. So there's actually 3 potential treatment mechanisms in a single system. The different activators that PeroxyChem recommends include alkaline activation, iron chelate, heat, hydrogen peroxide, and activation with zero-valent iron. We tend to recommend, and it's actually used most often in the study that we did a number of years ago, high pH or alkaline activation was used approximately 75% of the time. The reason for this is that it's actually very well suited for most applications. Part of this is just very practical reasons in that it is probably the technology that's most compatible with carbon steel. Carbon steel tends to be fairly prevalent in our industry in terms of that it's used to make most common DPT rods and in-situ soil mixing equipment. So if you had a project that was using carbon steel, like in-situ soil mixing or trying to inject through DPT rods, you'd probably be using and skewing towards alkaline activated persulfate. In addition, it's one of the technologies that forms all 3 of the pathways, the reductants, the oxidants, and the nucleophiles. Iron chelate activation is another very common activation method. It probably was one of the original activation methods. Basically, it's primarily, because it only generates the oxidative pathway, it's primarily used for hydrocarbons, different petroleum hydrocarbons such as BTEX, PAHs, DRO, GRO, as well as chlorinated ethanes, chlorinated ethenes. Heat activation tends to be used mostly as a polishing step following a thermal treatment, but it also can form all 3 pathways. Hydrogen peroxide activation can also form all 3 pathways, so you get the reductants, oxidants, and nucleophiles. But it's primarily used at sites where you want the vigorous reaction with both hydrogen peroxide and sodium persulfate. Zero-valent iron is not used currently all that much, but with the release of Klozur KP last year, it's in all likelihood going to be used in more and more. One of the advantages of zero-valent iron with Klozur KP is that it's a solid-state activator and that it's not going to be moved with groundwater, whereas Klozur KP is a solid-state oxidant. So that characteristic of the 2 tends to overlap. Whereas with alkaline, iron chelate, heat, and hydrogen peroxide, all of those can move in groundwater except for heat. Iron chelate, alkaline, and hydrogen peroxide are all liquid, so they can move in groundwater with the highly soluble sodium persulfate. With all 3 methods, pathways that you can have to treat the different contaminants of concern, activated Klozur persulfate can treat a very wide variety of different contaminants of concern. And really, this is just a partial list of different contaminants that we've seen activated persulfate treat over the years. These include your classic chlorinated ethanes, PCE, TCE, DCE, vinyl chloride, and they can be both oxidized or reduced. TCA, DCA, carbon tetrachloride are examples of compounds that need the reductive pathway in order to be treated. Then there's other compounds that go via the oxidative pathway only. For example, BTEX, TPH, different TPHs, GRO, DRO, PAHs. 1,4-dioxane needs the oxidative pathway. Then there's a number of compounds that some of which need the oxidative, some of which need the reductive, but different energetics, different pesticides, chlorobenzenes, etc. But overall, if you have any questions, you can contact us. But activated Klozur persulfate, one of the activation methods, is capable of treating all of these different types of contaminants. With that quick overview of the Klozur persulfate portfolio, I wanted to introduce Klozur One and also talk to you in essence how we view Klozur One. So what Klozur One is it's a single product where Klozur SP has been combined with the activator. The intent of this is to have a blend that just uses a single tank, a single injection system, where the designers only need to come up with a single design number for the overall system so that you can have a very simplified system in Klozur One. So basically, Klozur One is an activator and Klozur SP combined into a single product. It is 95% Klozur SP and 5% an activator blend. We're primarily trying to do this or introducing this product as to simplify the design and implementation of Klozur SP. So it is a soluble all-in-one product. Each of the components are highly soluble. Some of the key characteristics are that it's stable in the bag in that it's classified UN 5.1 oxidizer. So it can be handled in the exact same way as Klozur SP and Klozur KP. It's soluble once batched, and it stays in solution for the 2 to 4 hours that we recommend samples or batches to be injected within. And then it can aggressively treat the different contaminants of concern. A few other characteristics, we have included some pH buffer in it, and that we have multiple activation methods within Klozur One. So this is actually what Klozur One looks like. And for anyone that has implemented Klozur before, you're going to notice very quickly that it is a different color. Klozur tends to be a very clear solution. This, of course, is purple. The reason that it has a pink to purple color is the fact that it includes less than 1% potassium permanganate in the Klozur One blend. So the solution is going to be pink to purple, but the dry phase, you can also see in the picture here, is kind of an off-white, and it includes purple and black and brown little specks within the off-white material. So it has kind of a bit of a tan look to it overall with different little darker specks in it. So the activation methods within Klozur One, we have iron chelate and manganese. Both iron and manganese are transition metals and are basically cycled between different oxidation states. The reduced oxidation states are what activate the persulfate. For example, iron 2 activates the persulfate going to iron 3, then it needs to cycle back down to iron 2 and again activates the sodium persulfate. Manganese, permanganate is actually manganese 7, but as it goes to more reduced manganese oxidation states, the reduced oxidation states of the manganese can also serve to activate persulfate. So example, as manganese 7 is reduced to manganese 5 and manganese 6, it can then react with the sodium persulfate and activate the sodium persulfate, forming different radicals. We liked and added the multiple different transition metals to essentially build in a little bit of redundancy into the system, thinking that in some situations iron might serve as a better activator, and in other situations the manganese may. Because this is a iron or a transition metal activation system, it's primarily an oxidative pathway. So you're primarily getting either the hydroxyl or sulfate radical as the radicals that are going to do most of the damage in treating the contaminants of concern. This means that Klozur One is primarily aimed at treating different compounds such as total petroleum hydrocarbons, BTECs, PAHs, gasoline range organics, or diesel range organics. But it can also be used to treat chlorinated ethenes, your PCEs, TCEs, DCEs, and vinyl chloride, chlorobenzenes, and other compounds such as 1,4-dioxane. But basically, this is just a partial list. Anything that can be oxidized, we expect Klozur One to be able to degrade. So just to start showing some of the efficacy data that we have using Klozur One, I have a series of a couple of slides here looking at different compounds, and this is just your general BTEX compounds, a single time point taken after 21 days. The experiment was run at 20 degrees C with 50 gram per liter Klozur One. After the experiment, after 21 days and reacting with these compounds, 45 gram per liter of the Klozur One was remaining. Actually, the sodium persulfate was remaining afterwards. The reductions, as you can see, were quite substantial. Benzene by 99.1%, toluene by 99.9%, ethylbenzene by 99.7%, and xylenes, the different xylenes, ortho, meta, and para-xylenes, were all degraded by an average of 98.4%. Moving on to your chlorinated ethenes, same test conditions. PCE was degraded by 88% in this study. We've seen it degraded by even more in other studies, but this particular study, it was 88%. TCE by 96%. The different DCEs were degraded by anywhere from 94.6% up to 99.8% with 1,1 DCE. Finally, looking at a few different miscellaneous VOCs, chlorobenzene, monochlorobenzene was degraded under the same test conditions by 98.5%. Dichlorobenzene was degraded by 91.5%. 1,3,5-trimethylbenzene was degraded by 96.2%. Acetonitrile was degraded by 97.2%, and styrene was degraded by 99.9% in these studies. So you just saw a number of different compounds, a good amount of treatment efficacy, and that was all at 50 grams per liter. One of the other things that I wanted to illustrate was reaction kinetics, concentration-based reaction kinetics, and that with increasing concentration, you see more rapid treatment of the different contaminants of concern. In this graph, we look at benzene, or use benzene as the probe compound, And we ran it at different concentrations with different time points ranging from 4 hours up to 7 days, and concentrations of Klozur One of 10, 50, 100, 150, and 200 grams per liter. And what you can see is that within 1 day, the 150 and 200 gram per liter benzene was 10 milligram per liter benzene was non-detect within the 1 day time frame. It took with another by the 3 day time point, the 100 gram per liter system was non-detect. The 50 gram per liter was almost there. It was well into the high 90% reduction range. And then by 7 days, even the 50 gram per liter system, all systems above greater than 50 grams per liter Klozur One were non-detect. And the 10 gram per liter system, you can see, was in the mid-90s, or right around 90 to 95% mass or concentration reduction within the 7 days. So with increasing concentration, you saw increasing rates of reaction with the contaminant concern. The same was observed using TCE as a probe. Somewhat interesting in that a number of these points fell relatively on top of each other, but you see the same general trend where with increasing concentration, you saw increasing rates of reaction. The 10 gram per liter system had just a little bit over 80% treatment within the 7 days, but you start getting into the 50 to 200 gram per liter concentration range, and you're seeing treatment within 1 day from 150 and 200 gram per liter systems, and then treatment within 3 days of the 50 and 100 gram per liter systems of 15 milligram per liter TCE. So basically, the quick summary of all this, of course, is with increasing concentrations, you see increasing rates of reaction of the contaminants. We've primarily been talking about the oxidative pathway, very similar to alkaline-activated persulfate, where Klozur SP, sodium persulfate, is brought up above pH 10.5. Klozur One, being 95% Klozur SP, has the same kind of reductive pathway. In fact, though, because of the activator already being in there, we actually saw a little bit of enhanced kinetics in comparison to alkaline-activated persulfate. So you can get the reductive pathway within Klozur One, but you do need to add a second product. It's not going to be the simplified version where you just take one product, batch it in the field, and inject it. You would have to add an alkali material. One of the things that I just wanted to express and forewarn people about is that if you add a strong alkali to Klozur One, such as hydrated lime or sodium hydroxide, there will be some heat evolution, more than what you typically see with alkaline activation. Matter of fact, with alkaline activation, you typically see very little. But with Klozur One, you will see a little bit of heat activation. With higher concentrations, you can actually see substantial heat evolution. So please test this before implementing. The other thing that will happen is that you will precipitate out the iron and the manganese once you get above a certain pH, typically somewhere between pH, say 11.5 and 13. Somewhere in that range, the iron and the manganese, despite the chelates, will precipitate out. This could have some benefit. The enhanced kinetics could be advantageous in certain instances. So if you were doing a soil mixing job, for example, you might want to create the alkaline conditions, get this more aggressive kinetics, and the precipitation of the iron and the manganese would be less of an issue because, of course, with a soil mixing job, or if you're injecting through DBT rods, you can actually inject the solids. However, if you're trying to inject alkaline activated Klozur One through, say, wells, then the precipitated iron and the manganese might be an issue. Just to illustrate the reductive pathway, this is a slide showing the treatment of carbon tetrachloride. And the Klozur One, while it dipped down at the first time point, it basically moved back up, as we would expect it to be near the controls after 3 and 7 days. Whereas the Klozur One with alkalinity, the carbon tetrachloride continues to decrease. This study was run at a relatively low pH, a pH of about 10, 10.5. But what we saw with increasing pH, say if you were to get the pH of around 12 or so, the kinetics were even faster with Klozur One. A few other characteristics of Klozur One that we wanted to discuss to help people in handling and implementing Klozur One. First, it's going to be available in 55.1 pound bags or 25 kilogram bags and 2,200 pound or 1,000 kilogram super sacks. The transportation code is going to be UN 1505, and it's going to be the same DOT classification group, UN class 5.1 packing group number 3, same classification group as Klozur SP and Klozur KP. So in terms of transporting and handling it, Klozur One is going to be very analogous, very much the same as your other Klozur products that you're already familiar with. In terms of after batching it, Klozur One is very stable. This is one of the things that we've worked very hard to achieve. In the top right graph, you can see that at different concentrations, again going from 0 to 200 grams per liter, the lower concentrations over a 7-day time frame, very little Klozur One degraded, less than 1% degraded over that 7-day time frame. You get up into the 100 to 150 gram per liter range, somewhere around 10%, between 9 and 10% degraded in each one of those systems over the 7-day period. And then with the 200 gram per liter system, we saw a degradation of around 15%. We saw more degradation above 200 gram per liter, which is one of the reasons why we're trying to recommend that Klozur One be implemented no more than 200 grams per liter. The other thing that's very important in terms of dissolved stability is the temperature evolution. PeroxyChem does not recommend mixing our activators with Klozur SP under the classic conditions. This is because we have heard of a few instances where there was heat evolution coming out of those systems after an extended period of time. With Klozur One, we've run a number of studies, and as you can see in this graph, we did not see heat evolution coming out of any of the Klozur One systems. If anything, actually, as you look at the 0 time point, one of the things that you might notice is that the temperature dropped with increasing concentration. This is because the dissolution of Klozur SP is actually endothermic, and so it'll actually drop the temperature of the system a little bit. Here you see it drop by about 5.5 degrees Celsius. This is probably not something that's too unfamiliar to anyone that has batched Klozur SP in the system, especially on a hot, humid day. Oftentimes you'll see water beating up on the sides of your batch tank. But more importantly to this overall system, there was never observed, we ran this test multiple times, and we never observed any spike in temperature based on having the activator, this particular activator that is in Klozur One in with the Klozur SP. The closest we got is really at 200 grams per liter, and the temperature came up at about 3 hours to essentially the same temperature as the control. So in terms of stability, of the long-term stability of the Klozur SP, it's really pretty stable, but you do see some degradation with increasing concentration. And then in terms of temperature, again, it's really very stable in the experiments that we've run. A few other quick characteristics of dissolved Klozur One. As we showed you earlier, it does include trace amounts of permanganate, less than 1% permanganate, but this is enough to give a pink to purple color. As you can see in the picture to the left, 10 gram per liter has kind of a pink to lavender color. 50 grams per liter is getting into the lavender to purple range, and then of course 100 and 200 grams per liter, you're looking at a dark purple. We do not anticipate this color to stay or to persist into the subsurface. This is because there is only less than 1% potassium permanganate in Klozur One. So we expect the color to be consumed. Matter of fact, we're actually intending it to change color because purple is only the color of manganese 7, and to actually activate the sodium persulfate, we want the more reduced oxidation states of the permanganate. So even after batched, the color may change, and as the permanganate reacts and goes to these lower oxidation states to activate the persulfate, you could see some different colors. And matter of fact, in our laboratory, we have seen greens and blues and yellows in terms of the color as it changes with time. In terms of compatibility, we want to emphasize that Klozur One is very similar in terms of corrosivity to iron chelate activated persulfate, in that it has a rate of reaction. It does react with carbon steel. This is important because carbon steel is used to manufacture a lot of the DPT rods that people use to inject reagents and in soil mixing equipment. There are specialized DPT rods that are made out of stainless steel or have some sort of stinger that goes down through past the carbon steel that prevents the reagents from contacting the carbon steel that some contractors use to implement ISCO technology safely. But we just want to make people aware and make sure that you are considering this if you are going to use Klozur One for soil mixing or to inject through a carbon steel DPT rod. that you, in all likelihood, want to be looking at some way of protecting the carbon steel, or switching off and using some sort of material such as stainless steel that is compatible with Klozur One. The other thing, of course, that you can do for soil mixing is use classic alkaline activated persulfate, which has been injected through carbon steel DPT rods and is what is typically used for in situ soil mixing, because the high pH associated with alkaline activated persulfate tends to protect the carbon steel. With that, I'd like to move on to a few recommendations. In terms of injection, we recommend that Klozur One be injected at between 50 and 200 grams per liter. The final pore volume concentration of Klozur One is probably going to be anywhere from greater than, say, 10 grams per liter, but of course that depends on what concentration you inject at and the injection volume. But in terms of the injection volumes, to take advantage of some of these concentration-based kinetics, we do recommend having, say, a minimum injection concentration of around 50 grams per liter and a maximum concentration in around 200 grams per liter. Because of the corrosivity issue and the reaction with carbon steel, we do recommend injecting through constructed wells, through stainless steel, PVC wells, those types of things. Or if you are to inject through DPT rods, work with your contractor to make sure that they are using stainless steel wells, some other kind of material that is chemically compatible with Klozur One, or you have some sort of stinger that goes down and essentially eliminates contact between Klozur One and the carbon steel. We recommend that Klozur One be used to target contaminants that can be oxidized, including chlorinated ethenes, BTEX, PHs, diesel range organics, gasoline range organics, and chlorobenzenes. In terms of batching, one of the main advantages of Klozur One is actually batching. So where you can use a single pump to pump whatever you batch into the ground, because you no longer have to have dilution water, or you don't have to do inline mixing and blending the different activators with sodium persulfate. One of the great advantages now is that you can literally batch at your injection concentration. So if a design engineer located in an office, 1,000 miles away from wherever the site is going to be, this simplifies the whole process, because if you want to inject, say, 75 grams per liter or 125 grams per liter, you can batch Klozur One at that concentration. And so you can simply specify the amount of water, and you can specify the amount of reagent, and have that blended in the field in small batches and inject it. Regarding the small batches, we do recommend that Klozur One be injected within 2 to 4 hours of batching. As you saw from the temperature, we don't expect anything necessarily wrong or bad to happen, but this is generally good procedures to follow with the injection of the solution. In terms of batching time, the time it takes to dissolve Klozur One, all of the components of Klozur One are actually highly soluble, and they dissolve quickly. So if you have an adequate mixing system, we are expecting Klozur One, in that 50 to 200 gram per liter range, to be dissolved in the 5 to 10 minute range, depending again on concentration. A more higher concentration may be closer to the 10-minute, lower concentration may be less, but it really does also depend on how good of a mixing system that you have. And of course, even with the injection system and the batching system, chemically compatible tanks, pumps, fittings, gaskets, pressure valves, flow meters, any wetted part or part that might become wetted should be chemically compatible with Klozur One. In terms of on-site storage, most of our recommendations are exactly the same as we would recommend for Klozur KP or Klozur SP, in that we recommend following the NFPA 400 guidelines. We recommend storing in a cool and dry location, and typically we would want that not to exceed 45 degrees C. Of course, the cooler, the better, but not to exceed 45 degrees C, and low humidity system. Store in a manner that is secure from unauthorized personnel, and do not store near acid bases or reducing agents, near potential sources of fluid, or near sources of heat, and that all storage areas have proper egress. The one kind of difference that we would recommend for Klozur One is that, and while most people do this already, in that you want to minimize your time on site, so you basically quickly utilize whatever Klozur product you bring out to your site. There are a couple of facilities that have stored Klozur SP and Klozur KP for an extended period of time. For Klozur One, because the activator is in the bag, we do recommend that people basically do what the majority of people already do, which is order what you need for a site so that you are essentially storing what you need on site and you're batching and injecting it in a fairly rapid manner, say within a week or 2 weeks. That's a quick summary of Klozur One. And what I'm going to be talking to you now about is how we view Klozur One fitting into our overall Klozur portfolio. So first, our Klozur portfolio includes Klozur SP, which is based on environmental grade sodium persulfate. Sodium persulfate is a very highly soluble Klozur compound in that its solubility at 20 degrees C is approximately 570, 580 grams per liter. Klozur One is an all-in-one product that includes the activator, 5% activator, and 95% Klozur SP. So both of these, all components of Klozur One are also very highly soluble. Klozur KP is based on environmental grade potassium persulfate, which has a much lower, over an order of magnitude lower solubility than Klozur SP. And Klozur CR, the CR stands for Combined Remedy, and Klozur CR is a blend of Klozur SP and Permiox Ultra, giving you the combined effect of an ISCO treatment, chemical oxidation treatment with the Klozur SP, and the extended release of oxygen to stimulate aerobic bioremediation from the Permiox Ultra. Getting into a little bit of an overview of how we see each of these products being used, Klozur SP is primarily going to be used because of this high solubility. It's a great technology to be used to go in after source zone treatment, so you can get an awful lot of oxidant into your injection volume and inject that into the subsurface and establish contact where you're into your source areas. Klozur SP can be activated like with alkalinity, heat, or alkalinity, heat, or hydrogen peroxide to form the oxidative and the reductive pathways. So you can go after that very large suite of compounds that we talked about earlier. Also, alkalinity, the high pH helps protect DPT rods, the carbon steel and DPT rods, and soil mixing. Klozur One is essentially, being 95% Klozur SP, is essentially targeted at the same kind of site, source zone treatment, where contaminants can be degraded using the oxidative pathway. But the advantage of Klozur One, its real niche is simplicity, ease of use. Klozur One, you need one batch tank, you need a more simplified set of instructions, you need one pump, and you can be injecting your Klozur One. So it's an ease of use type of product. Klozur KP, because of that low solubility, it's going to be injected not as a liquid, but it's going to be injected as a solid or a slurry, or soil mixed as a solid or a slurry. We intend Klozur KP for permeable reactive barriers and treatment of low permeable soils. Because Klozur KP is to be mixed with its different activators, such as hydrated lime or zero-valent iron. Actually, don't mix KP with zero-valent iron. Those need to be separated, but you can do an upflow and a down gradient trenches with the ZVI, but it can be mixed with hydrated lime. You can get the oxidative and reductive pathways. Klozur CR is the combined remedy to get aerobic bioremediation following the ISCO application to get the 1-2 punch of ISCO followed by aerobic bioremediation. It also is going to be injected as a solid or a slurry. In terms of activators for Klozur SP and basically Klozur One, we're aiming that at simplicity. It is a transition metal very similar to iron chelate activation. It is a little bit different than iron chelate activation, but it is very similar. But it's aimed at simplicity, ease of use, convenience. Alkaline activation, you have the reductive pathway, but also because you can add enough alkalinity to offset the acid that's being formed from the decomposition of persulfate, the more sodium persulfate you have to add to the site, the more you might need something like alkaline activated persulfate to help offset that acid generation. So we do recommend alkaline activation for your highly contaminated sites. Also, one of the other benefits of alkaline activation is just very pragmatic. It is much more compatible with carbon steel, DPT rods, soil mixing equipment, etc. Hydrogen peroxide also gives you the reductive pathway. Also, we tend to see that being used at highly contaminated sites because you get the vigorous reaction based on the hydrogen peroxide decomposition reaction with the sodium persulfate. Also, there are a couple people that have selected hydrogen peroxide activated persulfate because they wanted to have the 1-2 punch of the ISCO followed by the longer-term residual from the oxygen. And then heat activation, we tend to see that used following thermal applications as a polishing step where thermal treatment was the primary treatment pathway, but then heat-activated persulfate, sodium persulfate, was applied following the heat activation or the heat treatment and was used as a polishing step. Another way to look at selecting of the activators, in terms of just site complexity, as something gets more and more complex, as you're dealing with, a soil mixing site, a site with extreme commingled contaminant plume, multiple different types of contaminants, elevated contaminant concentration, if you need the reductive pathway, we tend to recommend that you think Klozur SP with one of the customizable activators, where the activator can actually be tailored to your site. The ratio of activator to your Klozur SP can be tailored, and this can be alkaline iron chelate, hydrogen peroxide heat, or zero-valent iron. Zero-valent iron more for Klozur KP, but it can be used for Klozur SP as well. However, and this actually applies to a very large number of sites, if you have a site that is, relatively low in concentrations, and it's primarily a petroleum hydrocarbon site, then we absolutely recommend Klozur One. And you get the benefit of the ease of application and the huge benefit here where the activator is combined with sodium persulfate. So, in summary, the activation methods with Klozur SP absolutely still work. We expect alkaline activation. We know a lot of people that have been using alkaline activation successfully for a number of years, and absolutely expect that to continue to happen. The same with hydrogen peroxide, iron chelate, although maybe to a lesser extent as Klozur One includes iron chelate. But we expect all these other activation methods with Klozur SP to absolutely be used moving forward. What Klozur One, though, does is for certain sites, there is this benefit of combining the activator into the same product. So if you have a contaminant that can be treated with the oxidative pathway, your chlorinated ethenes, your petroleum hydrocarbons, you can take advantage of the all-in-one nature of Klozur One here. It's going to be handled and transported as a UN Class 5.1 oxidizer. We did a lot of work to make sure that the certain oxidizer blend is going to be stable in the tank once batched, and that Klozur One, in fact, was very effective with a number of different very oxidizable contaminants of concern. In terms of additional resources of Klozur One, of course, the biggest resources is always going to be our people. The PeroxyChem technical managers in each of the regions can be your first line if you have any questions regarding Klozur One, but of course you can also contact me directly and I'll be happy to help. But we also have a number of different documents that you can use. We have safety data sheets in a number of different languages, primarily aimed at North America right now, so French, Canadian, and English, but also over in Europe we have a number of different documents in different languages for the European market. We have a product sheet that's currently available on our website, an application guide that should be on our website very soon, and then a technical overview that will be coming soon as well, probably within a month or so. For more information, just to make people aware on all of our Klozur products, Klozur SP, Klozur KP, Klozur CR, and Klozur One, please see www.klozur.com. Just wanted to reiterate, Klozur One will be available in 55.1 pound or 25 kilogram bags and 2204 pound or 1,000 kilogram super sacks. It is going to be available in North America starting in late June, so essentially in next week, and it will be available in early August in Europe. So with that, Klozur One is one product combining Klozur SP, sodium persulfate with its activator, trying to create a ease-of-use product that uses one tank, one injection system, using a simplified single design, giving you Klozur One.